All right, today we're going to strap in for a pretty incredible expedition. We're not going to outer space, no, we're going deep inside our very own planet.
Think about it. You're standing on it right this second. But what is really under your feet? It seems like such a simple question, right? But the answer is, well, it's anything but. We walk on this ground every single day, but what's hiding just a few kilometers down? And what about thousands of kilometers?
And this image, it shows the whole thing perfectly. Our planet isn't just some solid ball of rock. Nope, it's built in layers, kind of like a giant onion. And each layer has its own totally unique properties. So let's start peeling them back, one by one, starting right from the top.
Okay, so our journey starts right here, on the surface, in a zone that scientists call the lithosphere. This is our home, right? It's the ground we build on, the land we farm, where we live our entire lives.
So what is it exactly? Well, the lithosphere is basically the rigid, rocky outer shell of the Earth. And it's not just the land you see, the continents. It also includes all that solid ground hiding under the oceans. It's the whole solid foundation of our planet.
You know, this really puts things in perspective. It's kind of funny. We call our planet Earth, but look at this. About 71% of its surface is actually water. It's that other 29%, that solid ground of the lithosphere. That's our focus. That's what we're going to be drilling into.
All right, let's start our descent. The very top part of this lithosphere is what we all know as the crust. It's the outermost layer, and believe it or not, it's by far the thinnest layer of the whole planet.
And it gets even more interesting. The crust isn't just one thing. It's actually made of two different sublayers. You've got the upper part, that's what makes up the continents. It's called CIAL, which is just a mashup of its main ingredients, silica and aluminum. Then underneath that, you have the floor of the oceans. That's a denser layer called SEMA, for, you guessed it, silica and magnesium.
Okay, this table gives us a great little snapshot. State, solid of course. Now the thickness, this is what's wild. It varies a ton. It can be as thin as 8 kilometers under the oceans, but it can get up to 50 kilometers thick under huge mountain ranges. The main takeaway here is that, relatively speaking, it's just a super thin shell.
Okay, we've punched through the crust. And now we're entering the absolute behemoth of our planet's interior, the mantle. I can tell you, the conditions down here are getting way more extreme.
So, what's the mantle like? Well, it's weird. It's not really solid, but it's not really liquid either. The best way to think about it is like thick, gooey, hot asphalt. And here's the kicker. It's constantly in motion, just really slowly. And this is so important because that slow motion churning is the engine that drives everything on the surface. Plate tectonics, earthquakes, volcanoes, it all starts right here.
And just look at that number, 85%. That is staggering. It's kind of hard to wrap your head around, but this one single layer makes up almost all of our planet's volume. That crust we were just talking about, it's barely anything in comparison, just a tiny little skin on top.
And as you'd expect, as we go deeper through this massive layer, the temperature just skyrockets. I mean, it starts at a scorching 1,000 degrees Celsius right below the crust, but by the time we get to the bottom of the mantle, we're talking an incredible 3,700 degrees. Just unbelievably hot.
Okay, we've made it. We're through the mantle, and we finally arrived at our last stop, the core. This is it, the very center of the Earth, a place with heat and pressure that are just beyond imagination.
So what's down here? Well, we're not dealing with rock anymore, not at all. The core is a super dense ball made almost entirely of metal. To be specific, nickel and iron. Geologists even have a little nickname for it, knife. Get it? Ni for nickel and Fe for iron.
Now this is where it gets really mind-bending. The core isn't just one thing, it has two parts. You have the outer core, which is liquid metal, and all the churning and swirling of this liquid iron is what actually generates Earth's magnetic field. You know, that invisible shield that protects us from all that nasty solar radiation? But then you get to the inner core, and even though it's hotter than the outer core, it's solid. How is that possible? Well, the pressure is just so incredibly intense, so crushing, that it literally forces the metal atoms to lock together into a solid.
This chart, this really brings the whole journey together. Just look at that tiny little bar for the crust. That's everything. That's where all life as we know it exists. Now look at the massive bars for the mantle and the core. It really is humbling, isn't it? A pretty powerful reminder of the incredible scale of the world that's right under our feet.
All right, so let's pull back for a second and just recap the whole trip, from the surface all the way down to the center.
Yeah, this is a perfect way to see it all at once. We started up top, on that thin, solid rocky crust. Then we plunged down through that huge, semi-solid mantle. And we finished our journey in the metallic core, with that liquid outer part and the super-pressurized solid center. Every single layer is totally different, and every one of them has a crucial job to do.
And that really brings us to the big takeaway here. Our planet isn't just some static, dead piece of rock. It's a dynamic, almost living system. That slow motion churning in the mantle, that's what builds our mountains and causes earthquakes. That liquid outer core, it gives us the magnetic field that keeps us safe. So the real question isn't just what's down there. It's how does this hidden, powerful world beneath us continue to shape the one we actually see and feel every single day? Something to think about, right?